chances are you walk past one of the most sophisticated biological factories in North America every day without even realizing it. To the casual observer, pokeweed is often a messy, overgrown eyesore, but to those who understand its true power, it's a living paradox of remarkable potential. On one hand, it's classed as an urgent public health threat, a botanical powerhouse that contains enough poison to shut down your vital organs in a matter of hours. On the other, it contains a protein so advanced, so molecularly intelligent, that scientists have spent decades trying to harness it as a magic bullet to hunt down cancer and HIV. But as new research is beginning to reveal, this deadly weed has a power far greater than anyone could have imagined. Its taproot system can suck in heavy metals, like the ones used in our electronics and batteries, and store it within the plant, a natural process that is essentially printing the exact resources that have become vital to our existence. So, what is pokeweed exactly? Where does it come from? And is green mining about to become the next billion-dollar boom? Let's find out. The story of pokeweed begins in a time when the color of a plant was as valuable as the minerals in the ground. The name poke does not come from a laboratory. It comes from the Algonquin word pukun, a term used by Native Americans to describe plants used for their vibrant red and purple dyes. For the indigenous peoples of North America, pokeweed was a vital resource for aesthetic and ritualistic expression. Its berries produce a juice so deep and so staining that it was used to color baskets, hides, and even human skin. By the mid-19th century, this weed became a vital source of ink. During the American Civil War, soldiers in the field, deprived of formal supplies, would crush the dark jewels of the pokeweed berry to write letters home to their families. The deep purple-red ink of the inkberry, as it was often called then, documented some of the most harrowing moments of the conflict. For centuries, pokeweed was a cultural staple in the American South and Appalachian cuisine. It was immortalized in 1969 by the song Polk Salad Annie. But the tradition of poke salad is a high-stakes game of botanical chemistry. It is a testament to human resilience, a story of people who learned to eat a plant that was designed to kill them. To eat the plant, our ancestors followed a strict, life-saving ritual. They harvested the shoots only in the earliest days of spring, before the stems turned that warning shade of neon magenta. They would then boil the shoots 3 separate times, discarding the water each time to leach out the lethal saponins and alkaloids. To get it wrong was to face violent illness or respiratory paralysis. But the shift in our relationship with pokeweed happened when we moved away from making poke salad and moved toward the safety of the sanitized grocery store and a wider selection of readily available safe food. The plant that once clothed warriors and fed pioneers during hungry winters was no longer required. In fact, it was considered a problem. In Western Australia today, it is a Category 1 pest. In Europe, it is tracked as a threat that outcompetes plants that have been there since the Ice Age. But in our rush to eradicate it, we miss the most incredible part of its biology. To the modern scientist, pokeweed is a defensive powerhouse. It uses a 2-stage physical and chemical weaponry system that rivals anything created in a military laboratory. If you were to look at a pokeweed leaf under a high-powered microscope, you would see millions of sharp, needle-like structures called calcium oxalate raphides. These are literally glass needles made of minerals the plant has mined from the soil. When an animal takes a bite, these needles pierce the soft tissues of the mouth and throat, creating thousands of micro tears. These cuts act as a biological doorway, allowing the plant's toxins to bypass the body's natural barriers and enter the bloodstream almost immediately. But the remarkable biology lies not in the needles or the toxins, but rather inside the plant's cells. In the 1990s, this weed became the focus of a medical revolution. Researchers realized that the pokeweed produces something called the pokeweed antiviral protein, or PAP for short. PAP is like a molecular sniper. It sneaks into a cell and effectively snips a single base out of the ribosomal structure, the essential cellular machinery. Once that base is gone, the cell loses its lifeline, stopping the virus from replicating. Scientists tried to weaponize this protein by hitching it to antibodies designed to seek out HIV-infected cells. In laboratory trials, the pokeweed protein outperformed blockbuster drugs like AZT by a massive margin. It didn't just slow down the HIV virus. It hunted down the factories within the body, where the virus was made, and shut them down permanently. Other studies showed that PAP could also target and destroy cancer cells while leaving healthy cells untouched. So, why isn't this in every hospital? Well, the answer is that the plant proteins were too unpredictable. Unlike synthetic chemicals, the proteins in pokeweed are genetically diverse. Every plant is slightly different. For a pharmaceutical industry built on standardization and patentability, pokeweed was a nightmare. Today, millions are spent on herbicides to kill a plant that was once promised as the cure for the world's most devastating diseases. But killing this plant is easier said than done. Pokeweed grows a massive, white, carrot-like taproot that can weigh over 50 pounds. And this root is like a subterranean bunker. It allows the plant to survive fires, extreme droughts, and the most bitter winters. A single pokeweed plant can produce tens of thousands of seeds, all of which are equipped with a time-release intelligence. They can sit dormant in the soil for 40 years, waiting for the exact moment when the soil is disturbed before they germinate. Pokeweed also has a remarkable allelopathic response. It releases chemical compounds into the dirt that effectively poison the ground for other plants. But as we enter 2026, our understanding of pokeweed is slowly undergoing a massive, strategic shift. We are moving from the era of eradication to the era of strategic phytomining. And the reason for this is that pokeweed is a hyperaccumulator. It has a biological hunger for heavy metals. This means this plant can suck cadmium, lead, and even manganese out of contaminated soil. While other plants die in toxic soil, pokeweed thrives, sequestering these nasty metals without any obvious ill effects. In late 2025, researchers discovered that pokeweed doesn't just store metals, it organizes them. These plants can grow functional mineral nanocrystals inside their tissues. What this essentially means is that we could be entering a new, uncharted era of green mining. The magnets in your electric car's motor, the screen on your smartphone, and the batteries in our grid all require rare earth elements like neodymium and lanthanum. And currently, these minerals are mined in environmentally catastrophic ways. But pokeweed is a biological vacuum for these elements. Instead of tearing up the earth with heavy machinery, destroying topsoil, and poisoning water tables to find rare earth elements, we could simply plant pokeweed. In 2026, pilot projects are exploring phytomining farms where pokeweed is grown on contaminated or mineral-rich land. The plants mine the deep earth with their massive taproots, bringing the rare elements up into their magenta stalks and dark berries. We then harvest the plant and biorefine it to extract the minerals. It is the ultimate circular economy. The plant cleans the soil, extracts the materials for our technology, and does it all using nothing but sunlight and water. It is an agent of phytoremediation, a term that means to use plants to restore balance. It takes the heavy, toxic legacy of modern industry and pulls it into its own body, transforming poison into valuable resources. And think about the scale of this opportunity for a second. There are thousands of brownfield sites across the world, abandoned factories, old mines, and contaminated landfills, where the soil is too toxic for housing or traditional farming. These sites are currently considered liabilities, black holes on the map of human progress. By planting the pokeweed on these sites, we turn these poisoned landscapes into a high-tech farm. And because the plant is so resilient, it requires no irrigation, no synthetic fertilizers, and no protection from pests. Its own chemical intelligence, the very toxins we fear, is its guardian against bugs and rodents. We have been conditioned to believe that the materials for our future must come from a place of scarcity and destruction. We believe that to harvest rare metals, we must mine and destroy our planet. Pokeweed proves that the Earth has already provided a more elegant way. It proves that the solution to our resource crisis is literally growing in the vacant lot at the end of our street. So why aren't we seeing pokeweed farms on the news every night? Well, it's most likely due to the fact that you cannot easily patent a wild plant that has been used by indigenous tribes for millennia. You cannot easily control a resource that grows from 40-year-old seeds and requires nothing from the industrial complex to thrive. If we transition to a world of green mining, the massive mining conglomerates lose their leverage. The chemical companies that sell the acids for mineral separation lose their market. Pokeweed is a threat to the status quo because it is a decentralized resource. It belongs to no one. Yet it is available to everyone who recognizes it, not the corporation that owns a patent. The pokeweed reminds us that our modern way of living is blind to the natural opportunities that already exist around us, and that advancement depends on corporations gaining control. So, their narrative is that a plant such as the pokeweed has no value. It is a toxic weed that needs to be destroyed, when the reality is that this could potentially be the most important plant on the earth. Every time we spray a fence line with poison to kill the pokeweed, we are killing a biological minor. We are killing a potential cure. We are killing a keystone species that supports over 60 species of birds and the beautiful giant leopard moth. So next time you see that reddish stalk leaning over your fence, consider the opportunity this plant offers our future. Look at your smartphone, electric car, or computer, and consider how brilliant it would be if all the precious metals used in these devices were collected using pokeweed. If this story helped you see the hidden treasures of the botanical world in a new light, then make sure to give us a follow. Our journey into nature's lost treasures is really just getting started, and there are so many more secrets waiting to be unearthed.